Alright, here we have an example of a system application problem. So, in this problem, in example 1, we have an amphitheater charges $75 for each seat in section A, $55 for each seat in section B, and $30 for each lawn seat. So if we just think about kind of what this problem is really saying to us, if I kind of draw a picture off to the side over here, we have an outdoor theater, so usually those are shaped kind of like this. They'll usually have a stage here, kind of an area there. So it looks like for section A they're charging $75, so maybe section A is this kind of middle section here. Section B might be a little further back, and then maybe you have the lawn kind of behind it. Okay, so in this 3 sections, it says there are 3 times as many seats in section B as in section A. Okay, so for instance, if we let some variables here, maybe we let x equal the number of seats in section A. So number of seats in A. Y will be the number of seats in section B, and Z will be the number of seats, or the number of spots, I guess. There's not always seats on a lawn, but number of seats in the lawn. Okay, so the first thing that we have, I think the easiest thing to first do is there are 3 times as many seats in section B as in section A. So if we think about that, Y, which is the number of seats in section B, has to be equal to 3 times the number of seats in section A. Okay, so that's kind of gives us an equation, a relationship between those two. Alright, then further on in the problem we see that the revenue from selling all 23,000 seats is $870,000. So some things to kind of note here. Notice that they're giving us a total, 23,000 seats. So we know that if I take all the seats from A section, B section, and the lawn, that it has to equal 23,000 seats. So in other words, in the algebraic terms, if I take the number of seats in A, or X, and I add that to Y, and I add that to Z, the total number of seats has to equal 23,000. So that's another equation that I can write down. X plus Y plus Z has to equal the 23,000 seats. And then lastly, I see that I have this other total, this revenue total, $870,000. That means that when I take the amount of money that I made from each section and add it up, I should get $870,000. Well, to figure out how much money I would make from selling seats in section A, well, it's $75 for each seat. So the amount of money I would make in section A is going to be 75 times X. The amount of money I'm going to make from section B is going to be $55 for every seat. So it's going to be 55Y. And then lastly, for the lawn, is charged $30 for every Z, and that has to equal $870,000. Okay, so now we have our 3 equations. We also have 3 unknowns. And we can get started on solving this problem once we get it set up. So now, when I look at my system that I've created, right, this is my system that I want to solve. I notice right off the bat that one of the variables is already solved for. It says y equals 3x. If I have, anytime I have, or if I have an equation where it's already solved for, I'm probably more than likely going to use a method called substitution to solve it. Okay? The way substitution works is I can take this first equation that has the variable equal to, and I can substitute that in for the y's in the other two equations. So for instance, my second equation will change. It'll end up becoming x plus 3x equal or plus z equals 23,000. Okay, so all I've done there is I've taken the y out and I've replaced it with the 3x. This third equation now can be rewritten as 75x plus 55 times 3x. So all I've done is replace the y with the 3x, and then plus 30z, and it still equals 870,000. Okay, and this is an 8. Okay, so I now have these two new equations. Okay, and all I've done once again is because y equaled 3x for the y's in the two equations below it, I just plugged in 3x. Okay, now I can use these two equations to simplify further. So for instance, if I look at those two equations, the first equation is x plus 3x plus z equals 23,000. Well, that is the same thing as, if I simplify it, x plus 3x is really just 4x plus z equals 23,000. And then I can do the same thing in this top one. I can simplify this. So I can take 75x plus, well, if I take 55 times 3, I'm going to get 165x plus 30z, and then that's still got to be equal to the 870,000. Okay, so I've now simplified these two equations. One is 4x plus z equals 23,000, and the other one is 75x plus 165x plus 30z equals 870,000. Okay, now with this I can do another substitution. Notice that if I minus 4x from both sides, the 4x's will cancel and I'll be left with z equals 23,000 minus 4x. Okay, I can then use this equation to substitute in for the z in my bottom equation. So I can rewrite this bottom equation now as 75x plus 165x plus 30 times 23,000 minus 4x, and that all has to equal 870,000. Now, because I have it all in terms of x, this just becomes just solving the equation for x. So I have a number next to parentheses. So the property we can use here is distribution. I can distribute this 30 to both terms inside the parentheses. So notice I haven't done anything with the 75x, so I'm going to leave it. I can't do anything with this 165x, I'm going to leave that as well. But I have distributed this. So if I multiply this out, well, that's going to give me, if I plug the 0 down, I'm going to get 0 when I'm 0 and 0. 3 times 3 is 9. 3 times 2 is 6. So I get 690,000 minus 30 times 4 is 120x. And then that has to equal 870,000. Okay. So all I've done so far is distributed the 30. Now I can combine like terms, so I can take this 75x, the 165x, and the negative 120x and combine them. So I'm going to put these three together. Well, if I start with these two, 165 minus 120 is going to be positive 45x. And then if I add that positive 45x to the 75x, I'm going to get 120x. And then I still have my 690,000, and that's going to be equal to 870,000. At this point, I can subtract the 690,000 from both sides. Notice that'll leave me with 120x on the left side, and on the right side, if I subtract these two numbers from one another, I think I will get 180,000. Let me just check real quick. So if I carry the 7 and the 17, 17 minus 9 is the 8, 7 minus 6 is the 1, and then the zeros will all stay zeros, so I should still have 4 zeros. So I believe it'll give me 180,000 seats. I then can divide by 120. I'll get x equals, now on this one, 1 0 and that 0 can cancel out. It's just dividing 10 from both numbers. And then I can simplify this by taking a 6 out of both of these. So if I take a 6 out of the top one, I'll be left with 3,000. If I take a 6 out of the bottom one, I'll be left with 2. And then I just divide this top number by 2, so I'll get x equals 3,000 divided by 2 is really 1,500. Okay, so as of right now, we just solved for x, which gave us 1,500. We've been doing quite a bit of arithmetic, so now we got to kind of go back and remember what's this value represent. Well, if we scroll back up to the top of the page, we'll notice that x equals the number of seats in section A. So in our amphitheater, in section A, we now know we have 1,500 seats. Okay. We then know that there are 3 times as many seats in section B. Okay, so if I have 1,500 seats in section A, I know there's going to be 3 times that amount in section B, and 3 times 1,500 is 4,500 seats. So far I have the number of seats in section A, the number of seats in section B. I now want to find how many are left in the lawn. Well, I can subtract these two amounts from the total 23,000 seats. So lastly, I just want to take 23,000 seats minus 4,500 minus 1,500, and that'll tell me how many seats are in the lawn. So notice that if I subtract these two values, I can put them together. So I'm really taking 23,000 minus 6,000, which will leave me with 17,000 seats. Okay, so if I look at how this amphitheater is divvied up, in the lawn there would be 17,000 seats. So it looks like there's a few seats in section A, just 1,500. There's a little bit more seats in section B of 4,500, and then there's a significantly more amount of seats in the lawn area, the larger area. There's 17,000 seats. So we've answered our question of how many seats are in each section of the amphitheater. Well, A would be 1,500, B would be 4,500, and then, like I said, the lawn is 17,000.